Let's take a look at the equilibrium calculation in the 2018 chemistry leaving cert paper. So this is question 9. We'll look at part D. So first thing we need to do is write out the chemical equation that's given, and we'll use this to form our ice table. Okay, so there's the chemical equation. Now prepare the ice. So I for initials, C for change, and E for equilibrium. So these are the different concentrations. We're told we've got 0.2 moles in 12 litres. So I'm straight away putting this into moles per litre. So I've divided the 0.2 by 12 and I get 0.0167. I'm keeping that to 3 significant figures. So I've rounded the recurring 6 to 7. So I've got the same number of moles of the 2 reactants and 0 products. Now I'm told 85% of my reactants dissociate. So I need to find out what 85% is of 0.0167. So I do that by multiplying it by 0.85. So there I have it. So the reactants are both going to decrease by 0.0142. So I'll put that into my ice table. The change for the reactants is minus that value. That's 85% of the initial concentration. And the product will gain by that same amount because the ratios of the reactants to product is 1 to 1 in this chemical equation. So the concentration at equilibrium will simply be the initial concentration minus the change concentration. So there I've got 0.0167 minus 0.0142. So that's my equilibrium concentration for the reactants, and that's my equilibrium concentration for the products, for the product. And all 3 of those concentrations are in moles per litre. So I can put them straight into the Kc expression. Now when I'm writing out the Kc expression, it's important to use square brackets. And I can see I haven't done that on the for the reactants and for the product on top there. But those are so be sure to use square brackets when you're doing this question. And so there's the answer, okay? And I've just worked out the units there. It's moles, or it's molarity to the -1.